good afternoon. My name is Ali Kujuri. I'm an adjunct professor at the Department of Engineering Science and one of the organizers of this engineering science lecture series on behalf of our department and also the School of Science and Technology. I would like to welcome you all to this ninth lecture of the series this year. And also I would like to thank Agilent Technology, who has been supporting this lecture series since the start in 2006. Before I introduce our speaker for today, let me mention that on the third, oh God, sorry about that. This is, I didn't change it last time. Basically, on the 17th of 2 weeks from now, we have an interesting lecture by Bruce Erickson. He is an engineering scientist from Agilent Technologies, and he's going to talk about the architecture of radio receivers, past and present. You'll be receiving the flyer later. But anyhow, for today, we have invited Dr. John Sullins from the philosophy department to talk about RoboEthics challenges in engineering ethical machines. Dr. John Sullins is an associate professor at the Sonoma State University, where he has taught for 6 years. His recent research and publications involve the study of computer ethics, malware ethics, and the analysis of the ethical impacts personal robotics technology is having in our lives. Dr. Sullins received a Bachelor of Science degree in Aeronautical Operations from San Jose State University in 1989 and Master of Art degree in Philosophy from Binghamton University in New York and PhD degree in Philosophy, Computers, and Cognitive Science from the same university in 2002. And here is John.
That looks like the right spot. Okay, well, thank you so much for inviting me today. And what I want to talk about is going to give an overview of what RoboEthics is, because it's a new discipline, and some of the ways that it's impacting engineering and our society in general. So, being a philosopher, I've got to start by defining some terms. So just bear with me with that, because I've got to be precise about what I mean. So the first term that we need to get a sense of what I mean when I say it is robot. What is a robot? Basically, it's just a machine that has sensors and actuators. That means that it could cover quite a bit. And in fact, there's many like self-parking cars right now that I think would count as robots, even though they don't sort of look like the science fiction version of a robot. So there's two distinct types of robots that we want to talk about, telerobot and autonomous. A telerobot is a robot that's essentially kind of radio controlled in some ways, but the machine itself might have some self-control. But the main distinction is that there is a user. It's controlled mostly by the user, and regardless of whether the machine has some self-control or not. Autonomous robots, on the other hand, the user input is limited to just the programming stage and maybe some commands during the operation of the machine. But in an autonomous state, the robot, makes a lot of its own decisions and defines its own actions. So both of those, we're going to talk about both of those types of robots today. The other thing we need to talk about is just give you like a 5-second course in engineering ethics. So what do I mean when I'm talking about engineering ethics? This is essentially what I mean. One of my mentors in philosophy and technology, Carl Mitchum, wrote this book, Thinking Through Technology, Engineering, and Philosophy. And this, I think, is just the distillation of that entire book. So what does it mean for an engineer to be working ethically? And that's when we construct a machine that's intelligently controlled and also furthers a moral good. That's really the important thing. So you have to know what end the machine is directed towards, and you have to know what effects that machine is going to have on the society around it. If you can do this correctly, then we can translate our intelligence about morality into active mechanical volition. So that's the goal here. Okay, the next thing we need to talk about, add to this mix, is social robot. So I know that robots have been around for a long time, but mostly they've been in the factory floor and that sort of thing. What I'm interested in is this new growth in robotics, which is social robotics, largely started by Cynthia Brazil from MIT. And she coined this term, and it basically is just building a machine that's socially intelligent, a machine that can interact with you in a way that's recognizably human. If it were a person, you might take it as a person. And ultimately, her goal is to try to create machines that we could actually be friends with. So that's quite a striking claim, and that's a fascinating book. I recommend it. And it's really caused me to think in the directions that I'm thinking. So RoboEthics, this is my definition of it. So it's just the design and study of robotic systems and their interactions with human agents. And can we design them in such a way that these situations are recognizably ethical, and can we justify what's happening, in the interaction between the machine and the people that are using the machine? All right. So what does it look like? So what I'm doing here, for those of you who might know some philosophy in the audience, I'm kind of mixing two ideas from philosophy. So I'm using a little bit of John Dewey, and I'm also throwing in a little bit of Mario Bunge, and their ideas that technology, that ethics is a technology, right? So this is what I'm working on. So what would ethics as a technology look like? Well, if we have some goal that we're looking to achieve, and the means to achieve that goal, and then the side effects of what would happen if we did implement those means, then we could come up with an ethical theorem that just looks like just a line out of logic, right? If you've got these means, then you're going to get the goal and the side effects. So you can form these sort of ethical rules, such as to get to our goal and our side effect, we should do M. And if we don't like the goal or the side effect, then we should refrain from doing M. Pretty simple stuff, right? So this shows, and you can get much more complex with this, but this is just an example of how it would work. And I think this example shows you that ethical norms can be rationally produced through the construction of the right set of conditional statements. So computers, as we know, are super adept at processing if-then statements. So computers should be able to do ethics. So ethics should be computable. At the very least, it should be computable in such a way that whatever ethical system we have designed, we should be able to find a way that a machine could implement that system, even if it couldn't reason it for itself. So the big question here is, do we have a theory worth implementing? And then what do engineers have to add to this? John Dewey is really famous for saying that ethics really is a technology, and therefore engineers are probably our leading ethicists, which is really odd because engineers don't always see themselves in that light, but perhaps they ought to. So we're going to look at a bunch of machines like this. I just thought I'd show some pictures of robots. So it's a robot that's designed to kind of enter your life and be part of your life. A cute little machine, right? I love this slide. I got this slide off of the NEC, the company in Japan, and the way that the people that built that robot that we're just looking at, what they're thinking of, and I think it's really an important slide because it shows that the machines have to be built well, right? They have to be built to run, and that's usually what we think of as a job for an engineer. But they also have to run within a social situation, and this sort of graphs out all of the other departments and disciplines that are required to make a machine that actually works the way we want it to work. So there's a role for artists, right? There's a role for sociologists, there's a role for philosophers, there's a role for clinical psychologists, there's a role for cognitive scientists, and there's a role for social psychologists, right? So a lot of people need to be in the discussion about the construction and development and implementation of a robotics project. And I'm here, right? Okay, so we've had this techno-fantasy for a long, long time, right? The automated house and you know, the little machine that does your wash and wraps it in plastic and puts it right in the bin, right, for you to use. This thing, like the, you know, Rosie the robot maid, right? So we've been wanting this kind of technology for many generations now, and the question is how far are we along with this? So it's, you know, we're well into the next century. Where's my Rosie the robot? Well, here it is. So we're a little bit behind in our techno fantasy. So we've got this, but this isn't, you know, this is an interesting machine. It's the first really commercially successful robot, and it's designed to sweep your floors. But I think that, you know, it's starting there. That's just sort of the first movement of robots into our home, and I think it will continue because we obviously want it really badly. And it's very different than the first robot that made it into the manufacturing world. So this is the Unimate, and it was made to stack light bulbs in a box. And it was made in 1961 in New Jersey. And so one of the things that I'm interested in RoboEthics is what did robotics do to the workplace, and was that positive and ethical all around? Because whatever it did to the workplace, it's going to also do to our house, our home, right? As we move more of these machines into our home, sort of the same things are going to play themselves out in our home that played themselves out on the factory floor. So I think that it's not obvious that this was really a beneficial move for workers in America. So I'm not really sure if it's really obvious that moving robots into our house is going to be beneficial to families, right? So that's one of the things that I'm interested in talking about. There's also kind of this weird sense of when we move these machines into our house. This is a frame from Lost in Translation, right? Great movie. And it's just kind of a quick throwaway scene in the movie, but it's I really like the way that, I mean, she's just obviously, it's like dealing with an alien creature. When these things come into our environment, they are so strange and so odd and so unlike us. So we're gonna transform the very social milieu that we exist in when these machines start moving into it. Okay, so now we're going to talk about effective and affective design in robotics. So I want to compare and contrast American and European robotics. So when American engineers set themselves to the task, American and European engineers set themselves to the task, we're going to build a robot. I want to build a robot. What do? Well, I get a military contract, right, is answer number one, right? So I just put a machine gun on it and figure out how to radio control it, right, and go shoot some people with it. That's like job one for robots. And then job two is how do I get this thing to clean my house so I don't have to, right? And so that's the two things that it seems to me, broadly speaking, Americans and Europeans think of first when they think robots. And then when you compare this to the Japanese and Korean response to robots, what's job one when they say robot? I'm going to build a robot. What should a robot do? Instantly they think it should play with our kids and it should be like my surrogate pet, right? So it's totally different mindset, right? It's two different, hugely different ways to approach the same technology. And I find that to be kind of interesting because we can obviously go down either of these roads in a strong way, which is the right road to go down. So one I'm calling effective robot design. So this is sort of the American and European way that you design robots. And what you do here is you think of the robot as just kind of a self-operating appliance. And you just take some task that you don't like to do. Shooting people is ugly and dangerous, so I'd rather not do it, but I still want to shoot people. So I'll just make a machine that does it for me, right? That's an effective robot design. I don't like vacuuming. I'll make a machine that does it for me. So, and I want to do this with as little human intervention as possible. So in this sense, robots become Muzak, right? They're sort of in the background. A Roomba is designed so that it comes on at night, vacuums your floor, and then it's back in its little plug before you wake up so you don't trip over it. Now this is, I want to oppose this with this effective robotics design. So in here, the robot is meant to be literally in your face, right? And in fact, it has a face to be in your face with, right? So this kind of machine is embedded, deeply embedded in the human life world, and is meant to elicit positive emotions. I find this to be a much more radical and interesting option. So it's sort of where I focus a lot of my attention on is how can we achieve this in an interesting way? How can we design effective robots? So a lot of this research is done in Japan. So we've got the RoboV, I think it's on 4 or 5 now, but this is the RoboV 3, which was designed to interact with children in kindergartens as a surrogate teacher. I don't know about you, I think I would have ran screaming from the room that thing. But Japanese children interact with it a little bit differently than we do, and they actually find it quite fascinating, and their scores in the classroom sort of go up when the robot's in the room. So there's a lot of interesting research that's been done with that. Here we have, in Japan, they're also really interested in studying robots and social psychology. So it's kind of experience I really wish that we could do here somehow. So they bring the robot into a social situation, don't really tell people why it's there, and then they watch how the people interact with it and learn how to make more and more effective robots that cause positive social interactions rather than negative ones. So how can we do this? One of the ways engineers approach this is to realize that humans have this natural tendency to anthropomorphize widely throughout their environment. So people are, for instance, people treat animals as other people, right? So we'll do this without much prodding. So all you have to do is realize, especially in Asia and even in the United States to some extent, people are ready and willing to treat robots as if they were displaying real emotions, even when they're not, right? Even when it's pretty clear that they're not. But people will give the robot the benefit of the doubt most of the time. So Brian Duffy, who was at MIT, he's now back in Ireland, but he's a robotics engineer. He tells us that we need to balance the anthropomorphic qualities and bootstrap these things and use them as an advantage for machines rather than seeing this as a disadvantage. So he's just arguing that we need to make machines that don't just sort of fade into the background, but move right into the foreground, because it's really what people want, and people are ready to interact with these machines as fellow people. This is sort of where it's at, state of the art in Japan as far as this is a what is this? This is I forget the name of the department store, but it's one of the big ones in Tokyo. And as you come in the door, this is the new greeter. So they fired the human greeter that used to be there, and this is a new sort of robotic greeter. And I was trying to get some video. I couldn't get any video of this robot in action, but it'll talk, right? Its mouth moves, and you ask it questions through the microphone, and then it tries to figure out what you said. So where can I buy perfume for my wife? It'll ask you, well, what's your wife like? And then it will make some recommendations for you. Obviously, people interact with this thing, but look at it, right? Obviously, there is no human agency there, right? I mean, it's really clear. Right? It's really clear. Yet, people will interact with it. They'll bow to it right afterwards. They'll treat it with all the social interactions that you would a normal person. So it's really quite fascinating. It's just a kind of a semi-smart mannequin. I don't know how much we want to get into this. We can wait for questions if we want to get into this. But there's Masashiro Mori wrote this really fascinating book. He's a robotics engineer and a Zen priest, and he has this really fascinating theory that the reason you find affective robots in Japan and not in Europe is based on Buddhism, because Buddhism allows you to believe in the possibility of affective robots, whereas in Christianity and in Islam and Judaism, machines are seen as kind of this sort of perverse subcreation of man and not part of the divine order. Buddhists don't have that psychological baggage. They see all human creations as creations of the Buddha. And so, of course, a robot shares in the Buddha nature, just like you would, just like this chair does, right? It's all good. So they don't have they're not creeped out by these machines the way people in the West are. So you see them everywhere, really taking off in the East. So these are all machines that are designed to sort of help you. There's that little robotic teddy bear is to keep elderly people entertained, because who wants to go visit them, right? So you make a machine do it. There's a really interesting wheelchair, right? A legged wheelchair that will walk you around. Really fascinating machine. This machine is Paro, and it looks kind of funny. This is sort of an earlier edition of it. The later edition is much better. I was at a robotics conference in Tokyo a couple of years ago, or not Tokyo, it was in Nara a couple of years ago, and I'm talking to the guy who builds this robot. They have booths everywhere, and Paro was there, and so I come up to Paro and I'm playing around with it, and I know a lot about robots and why they work and how they do things. And it was a really interesting machine. I'm playing with it, and I'm asking the guy some questions like how many people are buying this thing, is it available in America, stuff like that. And I realized after about 5 to 10 minutes of talking to this guy, I realized that just sort of subconsciously I had been petting Paro the entire time, right? As if it was like a cat or something that needed to be consoled, right, while I was talking. And so, I mean, it completely fooled me, and I know everything about these machines, right? I know everything about them. I know why it works and why it shouldn't fool me at all. But it really does. It's warm. It kind of purrs. You feel little sensors and things move underneath the skin, so it moves kind of like muscles, and it's just really a compelling thing to play around with. So they've got other things like this, the UML, which is meant to help the insomniacs, elderly, and lonely singles. So if you can't find somebody to have a baby with, you can always have a robot with yourself. this seems to bother us, right? So in the West, we also, we think of this in this sort of Pinocchio kind of way, like there's something really super creepy and sad about designing a machine to kind of be your child, right? This movie is the movie AI, which a lot of people hate, but Teed and I really like it, right?
The only two people on the planet who like it.
I think we're this is
wife.
the AI fan club meeting today. And I think it has a lot to say about RoboEthics, even if it has Macaulay Culkin in it. I'm pretty sure he is.
No, it's not Macaulay Culkin. It's Haley Joel Osment.
Oh, it's Haley Joel Osment? Is it? Okay.
Yeah.
Still a robot.
Yeah.
Mm-hmm. Still a robot. Great movie. But it kind of tells you how we think of this as sort of sad and tragic, and in the East they see it as positive and really fascinating. There is some work at MIT that goes down this effective path. So Cynthia Brezel being the most important of the researchers doing this. These are some of her machines. She sells a lot of her work to Disney and Pixar and those kind of people for amusement parks and that sort of stuff. Okay, so I'm not going to really go through this too much, but just to give you a sense of what a robotics engineer, these are two robotics engineers who are interested in effective robots. This is sort of a laundry list of what they think needs to go into an engineering project that wants to move down these roads. Okay, so I think that there are some ethical concerns with effective robots. Even though I think effective robots are cool, I still think there's some things we have to worry about. And the first one is we shouldn't really play lightly with human emotions. If we're designing a machine that's specifically designed to pull out emotions, we need to do that with a light touch. So my solution for this is to try to keep them like cartoon characters, right? So the emotion should remain iconic in the robot, so that it's clear that so that it's not really fooling me. One of the things that worries me the most about Paro is used as a robot to help as therapy for patients with dementia, and the patients with dementia that use this Paro. If you interview them afterwards, they often say, it was really nice to play with that seal the other day, right? So they're like thoroughly convinced that they met a real seal, right? That a real seal was brought in. And I just feel there's something disingenuous about that and maybe a little mean. Although the makers of Paro don't see that at all. So that's a conversation that we have to open and maintain. I think that these machines should be used to enhance the social world of their users and not further isolate them. So are we designing robots to entertain our elderly so that we don't have to go visit them, right, is different than if we're designing robots to entertain us and the elderly when we get together, right? Those are two different design concerns. And then this one, I think that effective robots is kind of a side effect of them, is that we're going to be able to learn a lot of interesting facts about social psychology and friendship that we haven't been paying attention to before, because a lot of people are now doing these experiments and using robots, and robot gives you something that you can control in the situation, and then you can learn a lot more about just what it means to the psychology of friendship is. So I think it's an exciting opportunity there. Okay. And how late did we go? We wanted to go today. Because I want to leave about 20 minutes for questions.
Yeah,
okay. All right, good. Yeah, because I have a few more slides to do. So what I wanted to do here was we've now seen kind of an introduction to what RoboEthics is, sort of in the big picture, what I mean when I'm using these terms, and some of the directions that engineers are going. And so now I want to pick on a very specific problem that's very, very directed towards us in this culture that we live in right now. So I think that our primary ethical concern with robots at this very moment is this particular robot right here. So this is a Predator drone, and these things are fly around the current war zones where we're projecting our military force. And they have a little camera right here, which is very accurate and can scan this whole sort of horizon. And they look around for targets. And then they're usually, I think this one, it's hard to see, they're usually a missile here and here. There's 2 Hellfire missiles on these things. And they can deliver these things with a reasonable amount of accuracy. Not a laser pinpoint accuracy like we're led to believe, but reasonable enough to get the job done. And so when our current set of wars started, there was, I think, 2 or 3 of these in operation. And currently, there is well over a couple thousand, right? So these things have grown exponentially. So this is the face of modern warfare, is telerobotics. So I have a much longer presentation on this, but I just want to kind of skip the highlights of what I've been writing about telerobotics. So I really find this to be a fascinating picture here. So this just is an Xbox controller, right, that's been adopted so that this guy can use I think this one is for the PackBot. So he's viewing a little thing that's happening with the PackBot through the PackBot camera, and then he controls it with Xbox controller, which he grew up his whole life, right, learning how to use, right? So he's really adept at using this. So what we're doing is we're kind of taking entertainment technology, turning it into lethal technology, and so I'm just interested in the epistemic question that's going on here. So that's a philosophical term, and it just means how do we verify what we experience as being true or being a valid experience. So when he's seeing the world through this system, is that changing the world that he sees and causing him to make some decisions over other decisions, right? This is what I'm most interested in. So in any epistemic system, there's going to be epistemic noise, and there's 2 locations of epistemic noise in this particular situation. One is the machine itself, right, the camera and the interface, and the other one is the preconditioning of this guy, right, what's going on in this guy's head already, right? So his life of video games, right, which he brings to the actual warfare, is going to color his decisions, right, as will the technology itself that's bringing him the picture of the battlefield that he's operating in. So there's been some interesting interviews with some of these soldiers. Like one of my favorites was a guy who was really excited, a Marine, after his first combat experience, and he said, it's just like Call of Duty. Okay, so this particular picture here is really interesting. So these are the guys who interact with that Predator drone. So think back to the picture of the Predator drone. It's flying over Pakistan somewhere, usually, or Afghanistan, and these guys are in Las Vegas. So they're at Creech Air Force Base in Nevada, and they've got a bunch of these. They're little trailers, air-conditioned trailers, and they come in and they sit there, and they're flying like all these video images and stuff. This is all coming from Afghanistan or Pakistan, and then these guys are operating the machine. Now you'll notice that they don't have to have their hands and eyes on the machine constantly, because the machine mostly flies itself. So this is what I mean about a telerobot, right? The machine is mostly doing its own thing, and then what you do is you just give it occasional commands. They could take over and fly it completely if they wanted to, but they don't have to. Mostly they just kind of set waypoints on these screens. The machine makes it there. They sort of review the data that's coming in. If they feel that there's a target, like the machine will say, I think this is a target, and then they'll say, they'll look at it. They usually, this phone here, they'll usually call a superior officer and ask, is this indeed a target? Do we have authorization to shoot? Yes, we do. And then one of these guys will actually, like the machine will say, this is the target, I'm ready to fire, I've got my missiles loaded, everything's go, and then somebody pushes the button, right? And then it actually fires. But that's essentially the only real human interaction with this machine is that final button push, right? All the other stuff is sort of programmed into the machine itself. So I'm interested in the lives of these guys, because this is a very different way to fight a war than I think has ever been done in human history. These guys show up, right? They get into their trailer, they fight a war many thousands of miles away. Their shift ends, right at 6 or so hours. The next crew steps in. These guys step out, and then they have 12 or 18 hours off or something like that. And so then they go home, and they live, right? They commute. They commute to this war. Right? They commute to this war. They go home, they play with the kids, have dinner, right? Watch TV, and then their next shift starts, and they drive back to Afghanistan, right? And so this is a strange thing, right? And we haven't done enough study yet as to what does it do. What does it do to you in your mind when you're killing people, playing with the kids, killing people, playing with the kids, right? It's a totally different way to fight wars, and it's just all changed within this generation. So I feel that because of the safety of these guys, right? The machine might get shot down, whatever. It doesn't matter. These guys are safe. This makes this politically more feasible, because nobody cares if the machine gets destroyed. Everybody in the world would care. Well, you would care if Americans were killed. But what we're doing with these machines, we're limiting the number of American casualties in such a way that it will become sort of trivial to make the political case to do these sort of adventurous wars. So I think that we might see many more of these kind of things happening. Certainly, these wars aren't ending, right? They've been going on longer than World War II, and there's no sign that they're really going to end. And I think it's because this technology allows it to be done relatively bloodless by us. So the other thing to think about is this sort of normalization of warfare. Warfare is a constant state. So more and more, these machines are getting smaller and smaller, and they're being flown by people who have less and less training, which is really interesting. So in the past, to be a pilot in charge of dropping really big, expensive bombs, you had to be an officer. But we're changing that in this generation. We're changing it to enlisted men. Enlisted men get to do this kind of job now. And I think that's really a big difference, because officers at least are trained in just war theory. Enlisted men just sort of go into the service and they go out. And so unless they happen to have gone to college and taken a class from me, they're not going to have the kind of training that they need to make the decisions that they're being asked to make with this kind of technology. Okay, the other thing that these machines tend to do is give us this sort of perceived antiseptic view of warfare, right? This is a war. That's a war. And it's clean, right? It's clean, it's far away. It's like a video game. It's in this sort of surreal virtual world. I play with it just like I play with a game. So are we collapsing this distinction between war and games and entertainment in ways that are creepy and unsustainable? So we've got this kind of myth of surgical warfare. Usually what I do here, I took these slides out, but when I do a longer presentation, I've got some slides of what the damage that these machines actually do on the receiving end, right? So it's quite gruesome, actually, if you're on the receiving end of a Hellfire missile, and they're not as accurate as you would like. So I've got some slides of a bunch of dead Pakistanis, and you go, yay, we got the terrorists. But it turns out that these Pakistanis were all allied to the Americans, and they just happened to be in the wrong spot at the wrong time. And I got another slide of a guy whose daughter was killed by a Hellfire missile just because they thought there was a terrorist in their house. But there wasn't. but the machine, wiped out the house with the little girl in it. So we have this sense that this is kind of a clean, surgical style warfare, when in fact it's the same old warfare, right? It's the same story that we've always. War is dirty and awful. War is all hell, says General Sherman, and he's right. And this makes us not see that, and that's what I'm worried about. Okay, so there's some people working on this particular problem. Just to mention, it's not just me, but these are sort of colleagues of mine. So the most important ones, like Ronald Arkin, is an actual robotics engineer, one of the best ones that we have in the country, and he has gotten really interested in this and has taken it upon himself to sort of learn a lot about philosophy, and has written some. He's got a grant from the U.S. Army to build a machine, what they call an ethical governor. So it would be a robotics technology that will cause the drone to have kind of an ethical, what am I trying to say, decision-making process within the machine itself. So as the machine is picking targets, it will say, this is within the rules of warfare, but unethical, and this target is within the rules of warfare, and it's an ethical target, right? And if it sort of works like a governor in a steam engine. If the system feels like it's past a certain point, it won't make it. Even though the guy might be pushing the fire button, the machine itself will say, "No, we're not firing. We're not firing."
So this
today.
is like a hedonic calculator, basically.
It's a hedonic calculator, right, for a predator drone, right? Mm-hmm. Yeah, fascinating stuff. So he got a big grant from the U.S. Army to build this. They've been backing off on it because when they got it, they said, "Great, let's take a look at what you designed." And they go, "Wait, it won't fire when I press the fire button?" No, I don't like that. Right?
Smart bomb
I don't like
refuses
that.
to go off.
Yeah, what they had intended was they wanted a machine that would fire even though the pilots thought that it shouldn't. So they were okay with a machine that would do that, but they weren't so okay with a machine.
Those are logically equivalent, right? If you just
Right.
transition.
Mm-hmm. Yeah. Well, that's the thing. It really matters who's designing this ethical governor, because all you have to do is flip some parameters, right, and it will do the opposite, right? The machine doesn't really know, right? It just follows parameters, right? So that's a really fascinating project to follow closely. Wendell Wallach and Colin Allen also wrote a book called Machines and Morals, and they tell us if the proponents of fighting machines win the day, now will be the time to have begun thinking about the built-in ethical constraints that will be needed for these and all robotic applications. Their argument is, look, there is so much money being thrown at this that it's going to happen. So we need to make sure that something like this is in these machines before they start getting really mass-produced. And then Michael and Susan Anderson, a team of one, the wife is a philosopher, the husband is a computer scientist, and they've been working on making an actual utilitarian machine that does hedonic calculus. And so that's a fascinating project as well. Okay, so we're at my last slide now, and so this is just sort of where I want us to think, and then we're going to have some questions and answer period. So I think that if we want to build effective robots, and I think they're a good idea in many instances, we just need to make sure that they're successful. And so they have to be the kind of machine that will help strengthen social bonds, not pull them apart. They have to be the kind of machine that will make war less likely, not more likely. And they have to be the kind of machines that don't seek to replace people and pets, but seek to enhance our relationships with other people and animals. And if we achieve that, we'll have entered a very interesting new era in human history. And if we don't, you guys have all seen the movies. Okay. All right, so let's get. I'll start here and then move on down.
And there are times both with human and then it's going to come, of course, with the robots, that affection comes in.
Mm-hmm.
When the affection comes in, even for us, depending upon what mood we are in, and then or what type of person we are, and so forth, we make a decision or not.
Mm-hmm.
And this, I think, is certainly is going to come, and then to the to the robots. For example, let's say that in Afghanistan, if you see like a little kid or a mother now maybe feeding a baby, then would I fire or not?
Mm-hmm.
I mean, what's happening in this area?
Mm-hmm.
When the affection is one of the parameters, and you need to have a logic for that,
mm-hmm.
and it's very tough.
Mm-hmm. Yeah, I think that's really fascinating. There was a great article in Wired magazine a couple of years ago about these robots that are used in Iraq to defuse bombs, right? And so it was talking about this one unit that did this and had a robot in it that they used to defuse bombs, and they named this robot Scooby-Doo. And so Scooby-Doo would go around and defuse bombs, right? But one day Scooby-Doo didn't defuse the bomb; it blew up and blew Scooby-Doo to pieces, right? It turns out so they said, okay, you lost your robot, here's your new one. And they said, no, we don't want that robot. We want Scooby-Doo, right? The real robot. And so they went and they got people, forced people to like strap this thing back together and get Scooby-Doo back in with their team, right? So this machine, that's just a tool, had become really like part of the band of brothers, right, in that particular unit. So there's already really deep affection that can be put into just a very minuscule kind of machine like this. Also, there's this book, Wired for War, in which one of the anecdotes that I felt was really illustrative in it was the drone was coming in danger. So we have a sniper, and it's got a squad of Marines pinned. And the drone is trying to take out this sniper, but the drone is under fire from some other things, and they felt that the drone was really in danger, so they pulled the drone out of the combat, leaving the Marines here pinned by the sniper, right? And so you're thinking, well, look, what's the purpose of the drone? The drone is to be destroyed, right? It should just go in there as much as possible. Maybe it gets destroyed, maybe it doesn't, but it's got a very good chance of saving these actual human beings. So there's a sense in which we're already starting to value these machines in comparative ways with other human agents, right? Even these very not very affectionate-looking machines. So you add the faces and all this stuff to it, and you're just going to triple and double that particular effect, I think. Mm-hmm.
Yeah. Well, one of the things Heidegger talks about this in What is a Thing, about one of the things that's happened that has made it so that we have a tendency to think of machines as interchangeable is because of mass production.
Mm-hmm.
And because, pretty much any Macintosh is like pretty much any other Macintosh. Mm-hmm. It's only when people customize it in a certain way. Mm-hmm. And, if you get in, the old, the literature of the 12th century or earlier, you have people have these really strong relationships with their swords or a piece of artifact.
Yeah.
And to some degree, I think that an awful lot of what makes our society, the sense of alienation that you feel that the sickness that people often attribute to materialism, it's more like it's an anti-materialism. It's that this abstraction is replaceable with any other abstraction.
Right.
And if people actually, one of the things I'd feel a little better about if the particular animal that these people were playing with, they had customized it in a certain way, made it their own, you've got much more of a situation of one individual relating to another individual, one of which is living and the other isn't living.
Right.
And it's a very, very different situation from every piece of machinery is interchangeable with any other piece of machinery. That naturally makes people think every person is interchangeable with any other person. Any person that can do this job can be replaced with the other job. And Heidegger really says that, the problem is we don't have enough respect for things anymore as individuals.
Right.
And that even transcends the issue of consciousness versus unconsciousness rather than, or persons versus thing or physical thing.
Yeah, you don't even have to enter that part of the discussion, right?
Yeah.
We can just talk specifically about things, right? And I totally agree with that, right? And I do think that's interesting. And so, what can robots add to that? One of the things that I've studied, I didn't really bring it up in this discussion, is the amateur robotics movement. Mm-hmm. So you can go, like next month is another one of these meetings in San Francisco, and you meet people that they're not from industry or anything, but they build these little machines. And you're right. There's this really interesting human connection. Like that's what I love about that community. Is like that, it's a real community, and it includes things, right? So it's people and things.
And every robot is different from every
right.
other robot because each person
right.
made their own.
Exactly. Yeah. So it's like a hot rod club, right? For total geeks. Yeah.
So you were talking about like the seal for people with dementia, and they felt like they were actually petting it. I was wondering if you had put any thought into like kids growing up with robots, them actually thinking when they're younger that it is real, human, until they get old enough to realize it's not. Like how
right.
it would affect someone like 10 years or 5 years and not long.
Right. Yeah, I do think about that, and I constantly use my own children as test subjects. So I buy them pretty much every robotic toy that ever comes out.
So when you come back from Japan with
all kinds of stuff.
All kinds of stuff.
Yeah. So whatever I can afford, I bring back, and it's all really interesting. But what I've noticed is, at least with my kids, right, is an initial fascination. And then it gets really boring, right? There's nothing more boring than a robotic toy. Like, there's nothing more interesting than a robotic toy out of the box, and nothing more boring than a robotics toy 2 hours later, right? And so I think there's something really interesting about that. But a lot of that,
divorce rate, I would imagine.
Yeah, a lot of that exactly. A lot of that is just due to the cost, right? How much computing power can we afford to put in a $20 toy, right? Paro is a $9,000 toy.
Oh, okay,
right?
that's wonderful.
So Paro is really cool, right? And Paro is like the kind of toys that maybe your kids might get, right? Because the cost might come down to where we can build something like Paro and have it sort of replace stuffed animals for this next coming generation.
I was thinking more like Rosie in the future. I don't know what it's but
yeah,
the robots,
yeah.
If it looked more human and it was
right.
made to the kids.
Yeah, that is dangerous territory. It really is, because kids are more credulable than they're like the dementia patient, right? So they're going to believe things that adults wouldn't believe. And you're absolutely right. It's going to really cause them to be to interact with their world in a very different way than the generation prior to them would have behaved. And then it'll get really interesting when those machines are good enough to fool adults, right? So that's a period that I see coming 50, 60 years from now. But that'll be a really strange period, right? When we're all kind of duped by this technology. You won't have to be a dementia patient to think that you're dealing with the real seal.
Because your point is we want to be duped.
We want to, yeah. That's the thing. We want it more than anything we've ever wanted, right? So we're going to do it. Right? We're going to do it. Yeah.
I have a little bit of comment. I want to tell you a story. When I was younger, I was in service. But before that, I used to follow fighters, jet fighters and all those.
Yeah.
Go into specs and all that stuff. Then part of my service, I was in front line. The war between Iran and Iraq.
Ah, yeah.
And I gotta say, what happened there wasn't so much, tanks firing, torpedoes coming or whatever, but the airplanes attacking.
Yeah.
I came up to this realization that those people up there have no clue, have no idea what kind of damage they are creating. They don't see the people. And this is exactly what is happening with these drones and all these robots. People are sitting in their own, let's say, backyard or whatever, and then pushing some button, not even having a clue that on the other side this is blood.
Yeah.
People are dying.
Mm-hmm. And the machine is designed so that you get the least amount of that experience as conceivably possible, right?
Yeah.
Well, we're going to make this sort of thermal images, right? And so, I mean, you're not going to have to experience that, right?
Yeah.
From your many thousands of miles away.
Yeah, and then nobody would know, nobody even would realize
Mm-hmm.
the damage,
Mm-hmm.
the catastrophe.
Mm-hmm.
So that is dangerous.
Yeah, I think that's just a really wonderful comment, and it's where we're going with this technology, and we're losing that sort of insight from that Wired of War book. Another great little anecdote, talking to a Marine veteran. And the Marine was talking about one of these episodes with a drone, and one of the things he said, which I thought was fascinating, is that, I feel more like a compatriot with the people I was shooting at than I do with the drone pilots, right? I'd rather talk to those guys. I'd rather be in a room with them, reminiscing, than with this guy right back in Nevada. So it's really odd, right? So there really is this distinction. The people that are on the ground and experiencing this are already starting to feel very alienated from the rest of their own services, right?
Well, look, maybe this ethical calculator of yours ought to make better images. I mean, if you could see, who you were killing, how cute they were, how young they were,
Yep.
you would probably be you could probably make these decisions. Though a human being could make these decisions, you wouldn't even have to have the robot make the decisions for you.
Yeah. So you've read my paper then?
I haven't. I
obviously,
just
right?
guessed.
Okay. Yeah. So.